In this video, we're going to finalize Newton's laws. We're going to apply them in different situations. We're going to understand the difference between mass and weight, first of all, be able to calculate the weight. We will investigate apparent weight, do some calculations on tension in lifts, and explain terminal velocity. Which of the following is true? If I take my pen to the moon, the mass will change. If I take my pen to the moon, the weight will change. Both mass and weight will change, or neither will change. Now, if you remember, mass is the amount of stuff inside an object. If I have an object, the mass is the amount of atoms, the matter inside. Okay. If I take this elsewhere, the amount of stuff inside will not change. What is this weight? If you remember, weight is the force due to gravity. So if I take this to the moon, on the moon, and I place it there, the mass will stay the same amount of stuff, but the weight will change because the gravity on the moon is much weaker than it is on the Earth. Same if you take it to other planets. It depends on the gravity of the planet. So the best answer in this case here would be, if I take my pen to the moon, the weight will change, not the mass. It stays the same. So, weight divided by mass. This is gravity. So you can say W equals mg, if you remember this formula. On Earth, gravity is 10. Actually, more realistically, it's 9.8. I know I keep saying 10, and that's a bad habit, but actually it should be 9.8 newtons per kilogram or meters per second squared. Both are fine. I'll say newtons per kilogram. W equals mg. On the moon, it's much weaker. So a quick question here. A student says his weight is 60 kilograms. Is he correct? Well, no, because kilograms is a mass. That's a mass. If you want to find the weight, you have to do W equals mg. mg. W equals mg, no problem. 60 multiplied by 9.8, or I'm just going to say 10, and I'll get 600 newtons. That is his weight. I have a lift designed to hold 5 adults. The mass of the lift is 500. The mass of each adult is 80. Calculate the weight when it's fully loaded, full with people. Okay, so W equals mg. We know this. W equals mg. The problem is we have a lot of masses. 5 adults. So you will do 5 times 80. So I know how many that is. That will be 400. And then I have the mass of the lift, which is 500. So I will do 400 plus 500, which is 900. So I now know that I will have 900, and then I'm going to multiply that by gravity, which is 10, and that means my weight for everything together is 9,000 newtons. Pretty heavy. What is the upwards pull and the tension when the lift is stationary? What does that mean? I have a lift. I have the 5 people inside the lift. 1, 2, 3, 4, and 5. Cozy. Very nice. Gravity pulling down is 9,000, 9 kilonewtons. I'm going to save myself from writing all the zeros by writing kilo. Kilo means 1,000. 9 kilonewtons. If this is balanced and it is not moving, the upwards force is exactly the same. It's also 9 kilonewtons. It's exactly the same. When it starts to accelerate up or down, if I wanted to bring it up, this has to be bigger. If I want to make it down, then this would be bigger. So we'll talk about that later. So now it's upwards. Its upwards force is 10,000. You need to calculate the acceleration. So A equals F over m from the previous lesson. No problem. 10,000. 10, 1, 2, 3. And I'm going to divide that by the mass. Not the weight, the mass, which is dividing it by 900. So now what I'm going to do is I'm going to take my calculator, I'll do 10,000 divided by 900, and I should get 11.11. Acceleration, meters per second squared. Done. Apparent weight. This is when we talk about the lift accelerating, moving up or down. We know weight is gravity, W equals mg. Apparent weight is when the forces are not balanced, when there is an acceleration. We did a little experiment on this, and we found that when the lift was at rest, the weight was normal. When it was accelerating upwards, the weight looks bigger, the lift is pushing up. At constant speed, it's normal again. If it's decelerating up, the floor is moving away from you. It's not pushing you up as much. The weight becomes smaller, slowly, slightly. If it's accelerating down, again, the weight was smaller because the lift is pulling away from you. And when it was decelerating, as in trying to stop, it has to push you back up again, so the weight is bigger. So that's something to think about. We'll get to the little mnemonic in a little while. Because we have a lift in a cable, we have an F net, so you do F net equals MA. There are two forces. You have tension and weight. You'll see tension is up, I will say up is positive, minus weight equals MA. This is the general rule that you would have for a weight. You will rearrange, you will take this to the other side, it will become plus or whatever you're trying to calculate. You can rearrange the formula. Tension minus weight. This is F net. Okay, same formula. Okay. 6 possible scenarios. Like I mentioned, you have a lift at rest, it's the same. At constant speed, it's the same. Accelerating up, you will add. You will do weight plus F net. This is little shortcuts for you. If it's decelerating up, you will do weight minus F net. Tension for the accelerating down is also minus. Tension for the decelerating down is plus. So that might be a bit confusing to remember. So what I did was I showed you AUDD is plus, DUAD is minus. Accelerating up or decelerating down, you add. Accelerating up, add. Decelerating down, add. Decelerating up, you will subtract. Accelerating down, you will subtract as well. So this is how you can remember AUDD, DUAD. Here is an example. 4 kilogram mass is sitting on a scale in a lift, it's accelerating up. What is the reading on the scale? That means what is the apparent weight. Apparent weight is the same as tension. So if you see something like this, or this, or this, these three terms are the exact same thing. So it's accelerating up, AUDD, accelerating up is plus, you will add them. So F equals the weight plus the net force, mg plus ma. You will do 4 times 10, 4 times gravity, plus 4 times 3, the acceleration. You will get 52 newtons. Here's another one. A mass of 2 kilograms is on a lift accelerating downwards. AUDD. DUAD. So AUDD is plus. That's a D, by the way. DUAD is minus. So it's accelerating down. It will be smaller. AD. This part here. Accelerating down. I will subtract. The tension is going to be the weight minus the net force. You will do mg minus ma. Put the numbers in. Mg, 2 times 10, gravity, minus ma, 2 times 4. And directly you get your answer of 12 newtons. So this is a little shortcut to finally get the apparent weight or get the tension and whatnot. The final thing is terminal velocity. Terminal velocity is the final speed, the fastest speed when you're falling. Because of air resistance, it will push you back up. As you start to fall, you will get faster and faster and faster, but eventually the forces will balance out. This happens when you're skydiving, for example. So you will see that you jump out, your speed starts off at 0 because you just jumped out. Here is the plane, and there I am in the plane. I am going to jump out of the plane. As soon as I jump out, my speed is 0. And I'll accelerate, get faster, get faster, get faster until I reach my steady speed. This is my terminal velocity. I will not get any faster than this, but now I am going too fast. What happens here? Well, if I am here and I am near the ground already, what I will do is I will open up my parachute. I have a big parachute, this big parachute. This will catch the air. It will catch the air, and that means it will slow me right down really quickly. It will slow me down. I will get slower. And I'll reach a new terminal speed, a new balanced force when the air has been caught up. And that is a slower terminal velocity, and I can land in peace.